Hello everyone. Welcome to lecture series on highway engineering. I am S. Logeshwaran, Assistant Professor, Senior Grade from the Department of Civil Engineering, KPR Institute of Engineering and Technology, Coimbatore. In this video, we are going to discuss about the introduction to highway engineering. So, the slide shows the definition for highway engineering. Highway provides maximum service to all. It is providing a door to doorstep service, maximum flexibility in travel. It requires small investments for the government. Motor vehicles are cheaper than other carriers like rail locomotives and wagons. It saves the time for the shorter distance. High degree of accidents due to flexibility of movement. So this is the only a disadvantage in highway engineering. The chance of accident rate is high when the vehicle rate increases. So this is the real definition for highway engineering. Next, we talk about the significance of highway planning. To provide a safe, efficient, economic, comfortable, and speedy movement for people and goods. So, this is the primary significance for highway planning. Second one, to plan for expected futures development and social needs to fix update wise properties for the development of each road link based on utility. And the third one is to optimize the usage of roads with the available resources from the nearby locations while they are doing the construction projects. This is quite convenient while we are providing the plain roads, but in hill stations, if the required material is not available, it will be a tedious process and we need huge investment. To work out a financing system is the last one. Yes, of course, it involves large investments, so we need to find the best alignment carefully. In social, economic, spatial, cultural, and political impacts of transportation. So, first one economic development, social development, spatial development, cultural, and political development. Modal limitations to sustainable development. Sustainable development, the development which meets the needs of present without compromising the ability of future generations to meet their own needs. And modal share is nothing but the percentage of total passengers or freight moved by a particular type of transportation. The next one is about the history of road construction in India. So, during various periods, many empires have developed the construction of road in various methods. So, first one Roman road construction, Trasghat road construction, Meklis road construction, Megdam road construction, and Stanlite road construction methods. So, first one Roman roads. Many of the early Roman roads were of elaborate construction. Some of these roads are still in existence even after 2000 years. During this period of Roman civilization, many roads were built of stone blocks of considerable thickness. It is extending over 580 km and was the earliest and best constructed road those times. They were built straight without any gradient. The soft soil from top was removed till the hard stratum was reached. The total thickness of the construction was as high as 0.75 meter to 1.2 meter. So this is the general layout of the Roman roads, and we can see here there are some vertical curbstones and it is having the thickness varies from 250 mm to 400 mm and large sized block stones at the top of the layer. The thickness varies from 100 to 150 meter and the bottommost layer is the hard stratum soil and the thickness is about 100 to 200 meter in thickness. So this is the extended projection for Roman road construction procedure. So first we have to soft soil has to be removed from until we get the hard stratum will be reached to the carriageway length. Bottom road was covered by 1 to 2 layers of large foundation stones laid in the lime mortar and having the total thickness of about 100 meter to 200 meter. And the second layer is large size broken stone mixed in lime mortar about 250 to 400 thickness. The third layer is small sized broken stones mixed with lime mortar about 250 to 400 thickness. Finally, a wearing course in the form of large sized block stones of 100 to 150 thickness should be provided at the top of the pavement. The second method is Tresgott construction. A French engineer, Pierre Tresgott, developed an improvement method of road construction in France in 1764. The total thickness of the road construction should be only 300 and thus he laid the foundation for the modern road construction techniques. He also emphasized for due to considerable of subgrade moisture condition and provision of camber at the top to drain off the surface water. Cross slope of 1 in 45 towards the center of the road. The shoulders with a slope of 1 in 20 should be provided to take away the surface water of the road to the side drain. Otherwise, we have to face the problem of pavement deterioration. So this is the general layout of the Tresgott road construction. So this is for your understanding. Next method is Macadam method of road construction. So Macadam realized that the stresses due to wheel load of traffic gets decreased at the lower layers of the road cross section, and hence it was not necessary to provide large foundation stones. He also insisted that the subgrade should be provided with the necessary cross slope to take care of the percolated water. So he is considered as the father of road construction in India. So there are two layers, each having the thickness of 100 of broken stones of sized 75 maximum. And as I said earlier, like the percentage of slope in Macadam construction is 0.75%. So the subgrades of a desired road width of 9 meter was prepared with a cross slope of 1 in 36. The first layer of 100 thickness of broken stones of strong variety and passing through 50 size and was laid and compacted. The second layer of 100 thickness of broken stones of strong variety and passing through 37.5 size sieve was laid and compacted. The top layer of 50 thickness consisted of stones of size less than 20 and the layer was compacted and finished in such a way that the cross slope of 1 in 36 appeared at the top surface also. So this is the comparison chart of Telford Macadam methods of construction. So first one, subgrade slope. In Telford's it is horizontal, but Macadam's cross slope of 1 in 36 was provided. Second one, foundation stones. In Telford's construction, large sized stones of size 220 at center and 170 at edge was provided. But in Macadam methods of construction, uniformed 50 size of bottom layer of 10 thickness pavement was provided. Base course regarding in Telford's construction method, 2 layers of broken stones of total compacted depth of 150 was provided, but in Macadam's method of construction, 1 layer of broken stones of depth 100 was provided. Surface goes 40 mm thickness with a cross slope of 1 in 45 in Telford's construction, and in Macadam's construction 50 mm thickness with a cross slope of 1 in 36 was provided. So finally, about the thickness of the cross section varied from 410 to 350 mm at edge, but in Macadam's it is uniformly of 250 mm size. So thanks for watching the video. In the upcoming lecture series, we discuss about the classification of highways.